Good day, everyone. Good day, everyone. We're starting a journey into logarithm. This is going to be the first part. And we have our learning objectives. At the end of this lesson, you should be able to, number one, identify the laws of logarithms. Number two, apply the laws to solve simple problems. And number three, you should be able to apply the laws to solve questions involving logarithmic equation. Yes. So those are the few things that we'll be checking out quickly, and we'll take a look at it one after the other. But before we move on, we need to establish the fact that there's a relationship between indices and logarithms. Yeah. By indices, we know we refer to index. So before now, you're expected to learn a couple of things in indices, including the laws, initial equation, or what you otherwise call exponential equation. So meanwhile, I want to establish a relationship between indices and logarithm. So if you have an exponential equation given of this form, in which case we have a equals to b raised to power c. Okay? So the rule says that this can be written as log a to base b equals to c. Okay, this is the transition that took place when you have something like this. So this b going to this place to become the base of the logarithm of a. So log a to base b will be equals to the power a become the value. That's the subject of the formula, which is what we have established here. Okay. Similarly, this is the same as this. The only difference is that what you have at the left hand side is now at the right hand side, and the form you have at the right hand side is now at the left hand side. So in any case, whichever form you're given is still referring to the same thing. So what do you do here? It is our y that comes to x to become the base. Yeah, it becomes the base here. Y becomes the base, and then you have log x to base y equals to z. So otherwise, we can call it z equals to log x to base y. And don't forget, this rule as it were, as you are moving in this direction, you can also move in this direction as the situation demands and require. Okay, so now, knowing that this is the law as it has been established as it is, let's take a look at one or two examples to demonstrate that relationship. So if you have h equals to 10 raised to power 2, if you're going to write it in logarithm form, what are you expecting to have? Don't forget, this 10 here is what will come here, and you have your log h to base 10 to be equals to 2. Okay, so similarly, 3 raised to power x equals to 9. Of course, you know, in this case, it is the 3 that will come to the other side to become the base. Okay, so which is what we are establishing. So therefore, x will be equal to log 9 to base 3. It's a law, it's a rule, and it's meant to guide you to solve a lot of questions, solve a lot of problems. Okay, so now, that being said, let's try to take a look at the laws one after the other. The first one is what we call the multiplication law. For multiplication law, it only says that if you have two values that are product of each other under the same logarithm to a base, you can use them to form two different logarithms to the same base. So this, you know, as we are moving like this, you can also move like this. So as the situation demands. So if you are given the log of a value to a certain base, and another logarithm is having the same base as it, so it means that if it is addition that's in between them, you can multiply the two values together. So which is what we're also demonstrating in this other form of it. So this is just to show you that the movement can be in this direction or this direction. So for example, you have log 4 to base 2 plus log 3 to base 2. You can see the emphasis on the same base value. So it means that you can write them as a singular logarithm to base 2. Then you multiply the two values together. So which will give you log 12 to base 2. Okay? So the second law is the division law. For the division law, it's similar to what you have in multiplication law, except that for multiplication law, addition means multiplication, while for division law, division means subtraction. So it means if you have something given in this form, you can separate it into this form. And if it comes in a separate form like this, and they are of the same base, you can write them in this form. Okay? So log A to base log m to base a minus log n to base a. Of course, this is the alternative form of the law, like the reverse form of the law. So this is simplified in this. You can see the base value are the same. So meaning that you can write as a singular log in that base. Then you divide this by this. Okay, so that will give you 81 divided by 9. Just do your regular division. So you have log 9 to base 5. So now we have the next law, which we call power law. So by power law, we're talking about the logarithm of a value that has power. So what it's saying is that whenever there's power on the value of a logarithm, so it means that power can come to the back to become a product of that logarithm to that same base. So this is the same thing as saying n times log m to base a. N times log m to base a. So another one that looks like it, which we can call the other part of a power law. Oh, we're going to check that out. Now look at this. So meaning that when you are simplifying the value, you can always be on the lookout to check the simplest index form that you can form from that value. Like for instance, in this case, for 27 it can be written as 3 raised to power 3. So, which according to this law, it means n is coming to the back, also 3 can come to the back. So this is as good as saying 3 times whatever you have here, which you can write as 3 log 3 to base 2. Now the alternative form of this law, the power law is, in this case, the power is on the number. Now when the power is on the base, yes, this law permits us to bring that base value behind too. But when you are bringing it to the back, it will now be 1 over whatever it is that you have there. So which is what has been simplified here. You have 1 over n log m to base a. So which is what you have there. And looking at this question you have here, you can see this can be simplified. The base is 9, and 9 can still be written as 3 raised to power 2, which of course you can bring backward. It's going to the back, it's going to be 1 over 2 times what you have here. Okay, we're going to talk more about that as we progress. Okay, so now looking at this, the next one is what we call identity law. Identity law says the log of a number to the base of that number is going to be 1. That's log 6 to base 6 is 1, log 2 to base 2 is 1, log 32 to 2. Now we want to combine some of the principles that we have learned so far. We know that from what we have, this 32 can be written in index form as index of 2. So that is meant to aid our simplification. So now, what do we do again? The 5 go to the back. So which we have 5 log 2 to base 2, and that's 5 times 1, and that will give us 5. So that's as simple as it is. Right. So now the fifth law, zero law. Zero law says that log 1 to any base is going to give us 0. So log 1 to is 1000, base 0.05, whatever the value is going to give us 0. Log 1 to any base is 0. So log 1 to base 10 is also 0, and log 1 to base 22. So you can limit. Now, inverse of logarithm. Okay, so for inverse of logarithm, if you have a logarithm given as log m to base a equals to 1 over log a to base m. So what we're saying is that this law was derived from a change of base, which we're not going to go into now. So it means that this can be written in this form. There are cases where that law will be required. So, taking a look at a form of it, you have log 2 to base 8 here. According to the law, we can write it as 1 over, there's the next change here, the base become the value, and the value become the base. That's what the law is simply saying. So in that case, we have this, which if we simplify further, according to our laws, we have this, and that will give us 1 over 3. Meanwhile, some of these principles that we're applying, if you look at it very well, you can actually apply a number of other things to solve the problem. So all of what we are trying to make us see is just the different sides to it. So whatever inclination you have in any case, even when you are solving, once it's still applicable, you can just apply it. It will still give you the required results. Okay, so from this, of course, we know log 2 to base 2 will give us 1. So that means we have 1 over 3 as our final answer. Alright, so now let's take a look at some questions. Example 1, simplify this. Okay, of course, something is common in each case. That's the fact that they all have the same base. This 3, this 3, this 3. So that means we can apply our law freely. But if they have the same base, you cannot. So this addition here, so what does it imply? It implies multiplication. This subtraction here, it implies division. So if you are applying that, of course, all of them will have a common base now, base 3, then you can then go ahead 9 times 21 and divided by everything divided by 7. That's 12. So from here we know 7 here 1, 7 21, that will give us 3. So that means we left with 9 times 3. So which, if you go ahead and multiply, you have 27, which if you do it further, of course 27 can be written as 3 cube, in which case we have 3 log 3 to base 3. Of course, we know log 3 to base 3 will give us 1, and we have 3 as our final answer. Alright, let's take a look at another question. We have log 5 to base 2 plus log 1.6 to base 2. This is the simplest of them all. You agree with me? You agree with me? So, what are we applying here? We're applying our multiplication law. We're applying our multiplication law. Okay, so we have that's log to base 2 of 5 times 1.6, which will give us 5 times 1.6 will give us 8. So which you can still reduce this further to this one, and you can reduce this further. That's 3 times 1, which is going to give us 3. Okay. Now, without using table or calculators, evaluate this. Of course, it's as simple as it appears. So what are we supposed to do here? Of course, we know that all of them are the same base. So meaning that we can apply the law straight up. Now the only thing we have to be very careful for is once a number is behind, we have to check it out. So that number, as usual, is coming to the front according to our law that we've established so far, which tells us that this will become the power of the value here. Okay, so from what you have there, you simplify further, you have this as the value of this, and if you go ahead and then apply, since there's nothing else to compare, again, this is the same base as this, and the same base as this. So don't forget, addition means multiplication, and subtraction means division. So what do? We just straight up log 2 is 5, that's 3 over 5 times 33, and 303 over 5 times 303 over 5 times 3,375 over 8. Then everything over 8, that's divided by 8 is 1 over 8. So if you go ahead and simplify further, you agree with me that this can be written as this, and if we change the division to multiplication, the flipping will occur with 81 over 8, changing to 8 over 81. So from here, you can do the division. 27 goes there 3 times. 27 in this, that's going to give us 125. 125. So 3 here, 1. 3 here, 1. 8 here, 1. 8 here, 1. So 5 here, 1. 5 and 125. That's 25. 25. So from there, you can then know that the only thing left here is 25. 1 times 25 times 1 over 1 times 2 times 1. That's going to give us 25 to 25. So which we can still reduce, simplify further to 5 raised to the power 2. So that means you have 2 over 5 to 25, and that's 2 times 1, and that will give us 2. That's our final answer. If this is still not clear to you, I would advise you just play it again. It will make a little more sense as we progress. Okay, so we'll move on. Let's take a look at another question here. Without using table of calculators, evaluate this. Okay, so from what we have here, this is similar to what we had just now, except for the form it is. Now you have to be careful that you don't say that this, everything now will be minus. What is at the denominator? The law is not applied that way. It's not applied that way. So the first thing you do, of course, you know that there is a 2 here, which you have to bring to the front according to our law, which permits us to do so. The law says that which permits us to do so. So according to the law, of course, this will become log 2. This will become log to base 2 of 1 over 2 squared. So which we can simplify further to give us this, that's log to base 2 of 1 over 4. And then we can still simplify further, of course, while we apply our law as relevant to this. So the law says that log 6 to base 3. We can apply the law. The law says that log 6 to base 2 minus log 3 to base 2. According to this, it can be written as log to base 2 of 6 divided by 3. So which is what we have done there, and to the numerator and the denominator. So from what we have here, this has been simplified further, and looking at our denominator, we do the needful. Okay, so from there, we can say we have log 2 to base 2 over log 32 to base 2. So we can go ahead and then solve this further, reduce this further. That's log. At the denominator, we have 32 being equal to 2 raised to 5. So which we can write in this way, as we apply the law further, and from there we have 1 over 5 times 1, so which will give us 1 over 5. So that's as easy as it comes. So let's take a look at this last law. Of course, like I said, the sixth law was derived from this law. We'll be checking out that detail. But we need to also identify and note this law as it were. Now, if you look at the law very well, what it's simply saying is that when you have log n to base b, you can rewrite the two logarithms as log n over log b. Meanwhile, both of them at that point must have a common base. That common base can be any value. You can choose anything to be the base, but whatever you use for what you place at the numerator must be the same thing you're going to use for what you're placing at the denominator. And most cases, of course, anytime that such is to be done, you use a number that will aid the process of simplification, even as you solve or simplify the equation further. Okay, so it's very important to take note of that. So this C is common in both cases. Okay, in the two cases it is common. That's the numerator and the denominator. So let's take a look at the equation here. We're using table or calculator to evaluate the following. Now let's take a look at the first one. That's log 3 to base 27. Even though you can use power law, that's the power law, that's the power base law. Yes, you can use that. But let's not use the power law in this case. Let's decide to use change of base in this regard. So by change of base, it means we have log 3 over log 27. So we decide to pick 3 as our base because if we put 3 can help us simplify this and this. Yes, that's why we choose 3. So we can't just choose any number, even though we can choose any number, because we have an objective to simplify what we have. So we choose a number that is relevant to what we are doing. Okay? So from what we have there, so that will give us, of course, we can simplify further to give us log 3 to base 3 over log 3 raised to power 3. That's 27 to base 3. That will be log 3 raised to power 3 to base 3. Okay? So from what we have there, we can then solve further. That means we have 3 log 3 to base 3. So which will give us 1 over 3 times 1, which is 1 over 3. So looking at the second part, log 32 to be 0.25. So from that question, anytime you have a question that has a decimal, the first thing you do is change it to fraction. That's if it doesn't make sense in decimal to you, just change it to fraction. So from what we have here, you agree with me that 0.25 can be written as 25 over 100. So from what you have there, you can then simplify further. That's 32 over 1 over 4. So which you can then use change of base to rewrite as log 32 over log 1 over 4. Now we decide to pick 2 because both of them, they are this index of 2 at one level or the other. So which you can go ahead and just simplify. So that means 32 will become 2 raised to power 5 and 1 over 4. If you apply your law of indices, is the same thing as 1 over 2 squared, which is 2 raised to power minus 2. Okay, so from what we have there, you can then go ahead and simplify further. You know the rule. This is coming to the back, and this 2 is also coming to the back, which is what has been simplified here. So from what we have here, so you can say basically 5 times 1 over minus 2 times 1. So which, of course, you know, your answer is minus 5 over 2. And to place it in a better perspective, we have to write it as mixed fraction, which is minus 2 whole number 1 over 2. Now, logarithmic equations. What do we mean by logarithmic equations? In the logarithmic equation, we're talking about equation that has a logarithm involved in it. So, the same way you have an initial equation, that you would otherwise call exponential equation, we also have logarithmic equation. It's just an equation that has logarithm involved in it. So, we will be applying all the laws that we have learned that have been stated and registered, yeah, in our that are registered, that we have learned so far. Okay, so from what you have there, looking at what you have here as a statement, what this statement is simply saying is that when you have log a to be the c to be equals to log b to be the c, what it's saying is that since the base and the log are the same, it means, of course, you can say you're dividing both sides by log to be the c. In another way, you can say that it implies that a equals to b, a equals to b, because all other properties are the same. So definitely our a will be equals to b. Now let's take a look at this question. We have to solve. We have to solve this following logarithmic equations. Log 4 to be the 2 plus log 7 to be the 2 minus log n to be the 2 equals to 1. Okay, so from what you have here, you can tell that we're simply applying laws of indices. We're applying law of indices as it were. Okay, so from here, of course, all of them are the same base. So that means our multiplication law can take its place here, and our division law can take its place here. That means from there, we can say the first question here will give us log to be the 2, 4 times 7 over n. Okay, so from what you have there, you can then go ahead and simplify further, which is going to give you 28 over n. And if you simplify further, before you simplify further, you remember our law, that's the relationship between indices and logarithm, as stated earlier, which is if a equals to b raised to power c, then log a to b equals to c. So this is the reverse form of it. You already have log something to be something. So don't forget, it is the other base value that is turning to base and the other side. So that means this law, which if we solve further, it's going to give us, that's 28 over 2. That's if we divide both sides by 2. Of course, that means our n is equal to 14. Okay, now let's take a look at the second question here. For the second question, you have log 36 to be this x equals to 2. We are applying the same law, meaning that log 36 to be this x equals to 2. So that means our x, as seen there, is coming to this side to carry 2 as the power. So which we're going to apply as stated here, 36 equals to x squared. So from here, few things you can do. You can decide to find the square root of both sides. You can decide to just apply laws of indices as it were. If 6 squared equals to x squared, so that implies that 6 is equals to x. So therefore, we can state that x is equals to 6. Now let's take a look at the last question there. The last question says log x squared minus 2x plus 5 to the base 2 equals to 2. So the same principle is going to be applied here, meaning that 2 will carry to here to carry it as the power. So from what you have here, this is going to give us 2 squared. Okay, so if you simplify further, you have this, and this will form our quadratic equation, which you can simplify further. And in the simplification, it gives us this as our answer. So we have x minus 1 equals to 0 twice. because it occurs twice, that is acceptable for you to write it that way. So we can say x is equal to 1 twice. It's as simple as that. So from what you have now, taking a look at the logarithmic equation further, let's solve the following questions. This is similar to what we have been solving. In any case, what you are just applying is the laws of indices, whether it's multiplication law, or division law, or power law, or you are making use of the change of base. So you're simply applying the law as it were. So from what we have here, let's take a look at the first question. Log x minus 1 to the raised 2 plus log x plus 2 to the raised 2 equals to 2. Now from what you have there, you have to simply apply the multiplication law as it were. So you have to apply the multiplication law, so which as it were, it means that you're multiplying. Now, while you're applying the multiplication law, don't forget the same rule that we've stated since it's still applicable, meaning that by reason of that, it means the 2 is coming to this side to carry the 2 here. Don't forget what you have here is what will be your power. This is what will be the base value by the time you do that. So which is what has been done here. And from what you have here, if you expand this further, you have this. And if you collect like terms, you simplify further, you have the resulting quadratic equation, which you can then solve further to get your final answer. Okay? So now for number big question of this example 6, we have this given. Don't forget the first thing you do, 2 must come to the front. So anytime you have something at the back, you have to bring it to the front before you can read that logarithm with other logarithm. And don't forget, I'm laying emphasis on this. This thing is only applicable because they have the same base. Because they have the same base. So let's simplify this. So if we simplify this, it gives us this. So from here, we can apply the multiplication law, so which we can then rewrite as this. So according to our law, that says that if the base, the logarithm is having the same base, it means you can just equate these two guys together, which is what we're doing here. So this implies that 3x squared equals 7.5. So you divide both sides by 3, that will give you 3x squared over 3 equals 75 over 3, and x squared will be equal to 25. So you find the square root of both sides, of course, times x is equal to plus or minus 5. So remember why, in this case of logarithm, it is only the positive value that is valid. In this case too, it's only the positive value that is valid. In this case, it's only the positive value. So x is equal to 5, and x is equal to 2 here. The reason is that if you put x is equal to minus 3 into this first equation here, that means we are having the logarithm of negative value. You can actually try it out with your calculator. Just put any negative value, just type log, so minus something. You will see that it gives you an invalid output. So, of course, it's just a way for us to double check it is not valid for us to have a logarithm in negative form. Okay? Alright? Especially for the scope of what we are dealing with. So, we move on to the last question on the list. We have log x with a plus log x minus 3 to base a equals to log 10 to base a. So if you have that as given, you can go ahead and just apply the multiplication law, since the a value is a value. So this can multiply this under a single base as given here. So if you multiply it by expanding it, this will give you this. And according to our rule, that says that since they both have the same log to the same base, then we can just simply equate them. Okay, so that means we form our quadratic equation, resulting quadratic equation, which you can solve further, of course, to give you x plus 2, x minus 5. Alright, so that will give us x equals to minus 2 or x equals to 5. Of course, we know that in this case, x equals to minus 2 is not valid, because if you put the value inside here, it will give you a negative value. So that means x equals to 5. You need to take note of this. Right? So we'll be checking out one last part of this logarithms. Now, logarithm of given values. In some cases, they can give you the value of certain logarithms, and you'll be asked to evaluate the entire logarithm. So in this case, you're not expected to use a table, and as much as possible, you're not expected to also use calculator. Anything that portray or that show that you engage another value without using the given value will make you not to get your full score, full mark as required for the question. So when you are given values in that place, except if there is no way to use it, you have to ensure you use it as well. Okay? Alright, so log 4.5 to the 10. So our first assignment is to ensure we reduce this guy to a form that will show something like 2 and something like 3. That's our objective. So the first thing, this is the decimal value, which you can write as a what's it called? As a fraction, as shown here. Okay, so you can write as a fraction. Of course, from here we know that the law we are applying is this. That's a division law. So, but before you apply the division law, you can actually reduce it to its simplest form. Then after that, apply the division law. So splitting it further, that means you have a log 9 to the 10 minus log 2 to the 10. So if you do that, from there you can then go ahead, of course, log 9 to the 10, written as log 3 squared to the 10. So if you solve it further, that will give you log 3 to the 10, of course 2 log 3 to the 10 minus log 2 to the 10. So what can you say regarding what we have then? You look at it very well. We have log 3 to the 10, we have log 2 to the 10. So what you just need to do is you just slot in the value as given in place of log 2 and in place of log 3. So we have it as given there, so that's going to give us this. Of course, can you use your calculator to get the value of this? Meanwhile, it's something that you can still carry out as elemental sum of the sort. Okay, so from what you have here, this will give you this, and that's your final answer. Okay, so with this, we've come to the end of the journey. So please the exercise here, I want you to attempt it and solve everything. If there is a part of this that is not clear, you can go over the video again, listen and watch as many times as possible. I believe there will be clarity as you progress with that. There will be clarity. I'm very sure of that. So use that to solve the questions that you have here. You can check out the other parts of the logarithm. They are talking about logarithm of numbers. So that will be coming up shortly.